second. So now to solve question number 14, we would have to, first thing is, we would have to revise what electrolysis was. Okay, so we have to have a brief overlook of what happens in electrolysis. तो ये पहले कर लेते हैं जल्दी से. Now, electrolysis by definition is when you have decomposition happening. एक सेकंड मैं बोर्ड यहाँ पे भी खोल लूँ. So electrolysis is when you have decomposition happening due to electric current being passed through something. So just one second, let me open it. A quick crash course on electrolysis. मोइज आपने किया हुआ ऐसा स्कूल में?
Yes sir, almost. Yeah.
ठीक है, चलिए यहाँ पे हम एक short quick crash course on electrolysis. So now electrolysis is it's decomposition of an electrolyte by passing current or electricity. By the passage of electricity. And what's an electrolyte? An electrolyte is something that has free moving ions. Anything that contains free moving ions, that's an electrolyte. What substances contain free moving ions? It's acids, bases, and salts. In aqueous or molten state, not in solid state. For example, NaCl, if it's solid, it's not really going to conduct electricity in aqueous molten state. So what happens in electrolysis is you've got 3-4 types of electrolysis. The first one is electrolysis of molten electrolytes. Now they don't have water in them. So electrolysis of molten electrolytes. Now, इस वाले में what happens is कि there is no water, so you've got a molten compound and there's going to be cathode and anode, right? And the two would be connected together through a battery. So they would be joined up. With each other through a battery. Okay, that's what's going on. And the solution is going to be a molten electrolyte. So let's say you've got magnesium oxide in molten state. Which side is the negative side? Which one is the positive side? क्या होगा? Which one is negative? Which one is positive?
The negative would be the smaller one, and that would be cathode.
Okay, the smaller one is the negative, and that's known as the cathode, and the positive side is the anode.
And
Okay, so the positive side is the anode. So that's your positive side, and that one is your negative side. So what happens is on the negative side, positive ions are attracted, so all the Mg2 plus are going to get attracted to it, and all the O2 minus would be attracted to the positive one. What happens at cathode is reduction happens at cathode. The battery is sending electrons, so someone has to gain electrons. So there is at cathode there is always a reduction that's happening, which is a gain of electrons. The battery is constantly supplying electrons, and on the other side you've got oxidation happening, and somebody has to there's a loss of electrons. So somebody needs to lose electrons because the battery is trying to take back electrons. So you've got only two substances, so there's no confusion. Mg is the one that's going to gain electrons, so it would form plus. It's going to gain two electrons to form Mg, and you've got on the other side you've got O2 minus, and that's going to lose two electrons. So you could write this as it's going to lose two electrons to form oxygen, which is diatomic. And since you have to form oxygen, which is diatomic, so there should be two oxygen ions, and in total they would be losing four electrons. Okay, Hamza, is this clear? Moise, clear? Rafe, clear?
Yes.
Yes, sir.
So that's the reaction that's happening. Uh, Reduction and oxidation. Now, what would happen if you had a aqueous solution, Carlith? And what would happen if you had an aqueous solution? Now, in an aqueous solution, I'm just going to copy paste this. I said in an aqueous solution, the rules are going to be slightly different because you have more ions in an aqueous solution. So, second one, let's do electrolysis of aqueous solutions. Now, in this case, pretty much the same thing is happening. And let's say my ions are different now. I don't have an MgO. Instead, I have something else like NaCl aqueous. So I've got NaCl aqueous now. Now, if I've got NaCl aqueous, then the solution would contain sodium ions, which would be attracted to, again, they would be attracted to cathode, and all the Cl ions would be attracted to anode. But there's going to be two more ions, and the two ions would come from water because now the solution has water, and remember, water, it partially ionizes and it produces H plus 1 and OH minus 1 ions. So it's going to produce a lot of H plus 1 and OH ions. The H plus 1 would get attracted to cathode and the OH minus 1 would get attracted to anode. TK, is this clear?
Yes.
I said now there's a competition. Who's going to gain electrons? Would it be Na plus 1 or would it be H plus 1? So how do you decide? The way you decide is the different substances have different tendencies to gain electrons and lose electrons. So you look at the reactivity series. And you look at the reactivity series and you look at the substance that's at the bottom of the reactivity series. That's the one that's going to, the one that is unreactive, that's the one that would let me rub this off. That is the one that would gain electrons. So the reactivity series is going to be it's going to be K, and then you have Na, and then Ca, then Mg, Al, Zn. So before Zn there's a C as well, but we can ignore that for now. Zn, Pb, and then you've got H, and then you've got Cu, He, Ag, Au, and PT. So you have to remember the reactivity series, and in the reactivity series, you've the one that's at the bottom of the reactivity series. That's the one. That's the one that would be the one that would be losing electrons. So who's at the bottom, Na or H? So that would be the one that would gain electrons.
H.
TKs, remember H is right at the bottom. So the equation is going to be that it's going to be H plus 1 that would be gaining electrons. But remember, H plus 1 is diatomic. So it would be gaining 2 electrons to form H2. And you should have a list of substances that are diatomic. A few elements are diatomic, like I'm just going to add it over here: H2, O2, N2. They're diatomic plus the entire group 7. You can just make sure which substances they don't form single atoms, but they're always diatomic. I said, what about the other side? It's OH minus 1 or Cl minus 1. There's another series at the other side, and that's I minus 1. You got Br minus 1, then you've got OH minus 1, and then you have Cl minus 1. And the rest of the ions are, they don't really matter. And again, it's the one that's at the bottom of the series. That's the one that is going to be the one that would be losing electrons. Okay, so you have to look at the bottom. So which one is right at the bottom right now? It's OH, right? And for OH, you have to remember this equation. When OH minus 1 loses electrons, it forms two water molecules, an oxygen molecule, and it produces 4 electrons. So you've got your equation at cathode and you've got your equation at anode. Okay, and you have to remember this OH minus 1 equation. Ye clear है सारों को?
Yes.
So you have to remember this OH minus 1 equation. Plus, at anode, you also have to remember that there's a thing about Cl minus 1, and that thing is that if Cl minus 1 is concentrated, then always Cl minus 1. So if Cl minus 1 is concentrated, or they say that the solution is concentrated and it has Cl minus 1, then always select Cl minus 1. I said, then you're going to always select Cl minus 1. I said, plus there are two other electrolysis types, which are active electrodes and inert electrodes. Okay, so the two other electrolysis types are active and inert, so we can quickly do that as well. The other types are number 3. Number 3 is active electrodes. And the most common examples for that is a copper electrode. Okay, that's the more common example. Achha, so active electrodes is, and let me take example copper and silver. These are made from slightly reactive metals. So these are made from slightly reactive metals, and these metals, they like to lose electrons. So an example for this is, so I've got these electrodes. So I have these two electrodes, and both of them are made from, let's say there's a battery in the middle, and I've got a cathode and an anode. Now, if these are made from copper, let's assume that they're made from copper. Now, if they're made from copper and I'm trying to electrolyze a solution that has copper sulfate aqueous, so my solution is going to have multiple ions. It's going to have copper 2 plus ions. It's going to have SO4 2 minus ions. There's going to be H plus 1 ions at cathode, and there's going to be OH minus 1 ions at anode. Okay, that's your positive. And this one is your negative. And this one is your positive. And so what's going to happen at cathode? Uh, Battery would send electrons, and the same thing would happen. It's either going to be copper 2 plus or it's going to be H plus 1. It's either of the two that would gain electrons. So according to the series, it's copper is right at the bottom. So copper is the one that's going to gain electrons. So it's going to be Cu. 2 plus, that would be trying to gain 2 electrons, and it would try to form copper. ठीक है, Muiz or Rafe, is this clear?
Yes.
Yes, sir.
अच्छा, this side is the same as before. ठीक है, no difference. यहाँ पे वही हो रहा है जो पहले भी हो रहा था. ठीक है, it's exactly the same. The other side is going to be different because metals like to lose electrons. So battery is pulling electrons. So who's going to lose electrons? Previously, it was decided between the two, like who ends up giving or losing the electrons. Now the problem is it's going to be the metal that would be the one that would be losing electrons. ठीक है? So copper 2 plus plus 2 electrons. Is this clear?
Yes, yes.
So ये difference है. And this one is very important. You have to remember. You have to remember the observations as well. The observations are going to be that a pink metal would be formed over here, and the copper over here would start dissolving. That's the observation. Nothing would happen to the solution. The solution remains exactly the same. So पहला काम तो ये करो कि quickly now try, and I'm going to give you 3 questions. ठीक है? Send me बस rough diagram के साथ ना send me the answers for, let's say it's MgCl2 in liquid molten state. Electrolysis karo, उसी तरह cathode anode, give me the equation, make a diagram like this. So just a rough sketch. Second one, you got second one is you got silver nitrate aqueous. And the third one is NaBr aqueous. बस ये, I mean this is MgCl2 liquid. Try and send me the solution exactly जैसा मैंने किया हुआ है ना. Just make a rough diagram and send me what the answers are. कि concentrated NaCl है तो और aqueous भी है, तो इसका मतलब है कैथोड के ऊपर there's going to be Na plus 1 and H plus 1. तो कौन सा आयन डिस्चार्ज होगा कैथोड पे?
Hydrogen.
ठीक है, तो वो H plus 1 would gain 2 electrons to form H2. And on the other side, you've got Cl minus 1 and you've got OH minus 1. ठीक है, तो हमने नोट्स में लिखा है कि अच्छी वैसे आ गए यहाँ पे. अच्छा, ये था तो ठीक था. अच्छा, इधर we wrote down in our notes that कहाँ पे कि OH is lower down, so it likes to lose electrons. So OH होना चाहिए, but if there's Cl minus 1 and it's concentrated, then it's always going to be It's always going to be Cl minus 1. So which is why in this case, since he's using a concentrated amount, so Cl minus 1 is going to be discharged, and it's diatomic, so it's going to be 2 Cl minus 1. They would be forming Cl2, and they would be producing 2 electrons. So it's going to be the product at cathode is going to be hydrogen, and the product at anode is going to be chlorine. Okay, is this clear?
Yes.
So when negative ions, which negative ions are present in aqueous copper 2 sulfate? So which
Sulfate and hydroxide.
Okay, so these two ions are going to be present. So next is about energy profile diagram. So first thing, is this an endothermic reaction or an exothermic reaction?
Endo.
Okay, this one is an endothermic reaction, और इसको उधर जाके ना board पे we can just discuss this briefly कि अच्छा when you बस जल्दी हो जाए अच्छा now when you have yeah okay. When you have an endothermic reaction, the products are always at a higher energy. Uh, so the reactants have lower energy. That means they've gained energy. So the net difference is known as is. How would you label this arrow? What would you call this?
Activation energy.
नहीं,
Sorry, delta H.
ठीक है. This is known as delta H. ठीक है, that's the net change. ठीक है, the net change is you go from your reactants to your products. What is this thing? ठीक है, all arrows are going to start at your reactants. What is this value?
Activation energy.
ठीक है, that's the activation energy. That's the energy that is needed to start a reaction. Now, in any reaction, you first gain energy and then you lose energy. ठीक है, if you're trying to burn wood or paper, you would first give it energy and then it would produce energy, right? Why is energy needed at the start? Why is there an activation energy or energy that's needed at the start of a reaction? क्या reason है?
To break the old bonds.
ठीक है, so that's for breaking old bonds because breaking bonds is endothermic. That requires energy. So you would have to break bonds, and then energy is released when bonds are formed. So a reaction overall has both things happening. There's an endothermic part and there's an exothermic part. Now, overall, the reaction is endothermic when if more energy is taken in and less energy is given out. And overall, the reaction is exothermic if less energy is taken in and more energy is given out. So, exothermic, the products are going to be a lot lower. So, the reaction the reaction is endothermic in what direction? In the forward direction. Okay, in the forward direction, it's endothermic, like going from reactants to products. Coming back, you're losing energy. Is that clear? So the backward reaction is exothermic. ठीक है, ये बात clear है?
Yes.
अच्छा, and he's also asking which one has the greater activation energy, the forward or the backward. So in the forward direction, this is the activation energy, right? What if you were going in the opposite? What if you were going in the opposite direction? ठीक है, you're coming back. Everything would be the opposite now. You're trying to come back. So initially you require this much energy. Right? You're trying to come back. So initially you would require this much energy. So the activation energy in the backward direction would be lesser. It would be smaller. Is that clear?
Yes, sir.
Forward direction where the activation energy is going to be a lot higher. Okay? In the forward direction you would need initially you would have to climb all of this, you would need this much energy. So it's going to be uh, the activation energy is going to be higher, but in the forward reaction. ठीक है, clear है सारों को?
Yes, sir.
Yes, sir.
That's the next one is the table shows like compounds getting burnt, or I mean they're burning, right? So which compound releases the least energy when 1 gram of is completely burnt? I said remember this is per mole. What is the mass of 1 mole of a substance? The mass of 1 mole of the substance is basically the MR of the substance. Like remember, molar mass is the mass of 1 mole of the substance, and that's equal to the MR. Because you had a formula which is moles equal to mass divided by MR. So if you have 1 mole of a substance, so if you put 1 over here, mass would be equal to MR, right? Is this clear?
Yes.
Yes.
Achha, so the first one is enthalpy change per mole. So that means that's the enthalpy change for 78 grams of. I mean, that's equal to the MR. The mass would be equal to the MR. So the enthalpy change is given per mole. So that means the mass of fuel that's being burned is 78 grams. In the second one, heptane, it's the energy change is also per mole. So the MR is 100. So you're burning 100 grams of the fuel and you're getting this much energy. And so you're getting 114 grams and 44 grams of this fuel. So which one produces the least energy per gram? So this is the energy that's being produced by 78 grams. So divide these values by 78, you'll find per gram. So what's 3270 divided by 78? And so on.
Sir, won't we multiply?
कौन सा?
Sir, won't we multiply?
नहीं, डिवाइड पर ग्राम निकालना है ना. Well, 1 gram का निकालना है ना. So 78 gram produces this much. So what would 1 gram produce? So you're going to
4.41.9.
किसका पहले का?
Yes, sir.
What about the second one?
48.
So that's minus 48. Third one.
48.3.
Because that's minus 48.3, and the last one is
50.
the last one is 50. So इसका मतलब है the first one is the correct one. The least energy per gram. ठीक है, is this clear?
Yes, sir.
So then the next one. This is about rate of reaction. Experiment is carried out to measure the rate of the reaction between magnesium and dilute hydrochloric acid under two different conditions. The mass of magnesium and the number of moles of hydrochloric acid are the same in both experiments. So, first thing, what's the reaction between Mg and HCl? What is going to be produced?
MgCl2 and H2.
So MgCl2 and H2 are going to be produced, and this is going to be 2 HCl. Okay? Now we've got this reaction happening, and he's measuring the volume of gas, which is basically H2. Now, in the rate of reaction, any change with respect to time is plotted, and that gives you how fast the reaction is happening, or how fast that change is happening. So H2 volume increases. The steeper the graph, the faster is the reaction. So which one is the faster reaction?
1.
Okay, so remember that's the faster reaction, and the second one is your slower reaction. Now there could be a number of factors for there are 5 factors that affect the rate of reaction. What are those five factors? The five.
Temp-
ठीक है, one of them is temperature.
temperature.
So, buddy, the first one is temperature. Why does increasing temperature speed up the reaction? What's the explanation for that?
It decreases the
Huh?
kinetic energy of
ठीक है,
particles.
ठीक है, it increases the kinetic energy of the particles, and there are more frequent collisions because the particles are now traveling faster, and they would bump into each other more. So there's more frequent collisions. Plus, they're going to be more successful or effective collisions as well. Because not they're going to hit each other with a lot more force. So the chances of reaction happening is also going to increase. So two factors. Uh, the forcefulness or the effectiveness of the collisions increases, plus the frequency of the collisions increases. What's the other factors? What's number two?
Concentration.
I said number two is concentration. Now, in concentration, if you have a solution and you have more concentrated particles, so they would be closer together and they're going to bump into each other more. So, concentration, only the frequency of the collisions would increase because you have more particles per unit volume, right? What about pressure?
Decreasing pressure.
Nee, if you increase pressure, what happens?
Volume will decrease.
Okay, so if you increase pressure, there would be more frequent collisions. For example, over here, if I increase pressure, and just a second, volume decreases. I mean, this is an example of that. So I'm trying to increase pressure. So the gas particles would be closer and closer together. It's going to compress, and when it compresses, the particles are closer together, so they're going to bump into each other more. So the frequency of collisions would increase. Okay. But the thing with pressure is you can't really use pressure over here because pressure is for gases. This is a solid and this one is a solution. It's aqueous. So over here, pressure is not going to be a factor in this particular case. Pressure is a factor only for gases. Is this clear?
Yes, sir.
Yes, sir.
Similarly, concentration is only going to be a factor for solutions. Now, HCl is a solution, so it's going to be a factor. But if there were solids and gases, then concentration would not really be a factor. What about number 4 and 5? What's 4?
Particle size.
Okay, that's particle size or surface area. Okay, powder is going to have a higher surface area, more collisions would happen. So again, frequency of collisions would increase. So remember, in all four, frequency of collisions increases, but in temperature, the effectiveness or the forcefulness of the collisions or the successfulness of the collision also increases. What about the last one? क्या था last?
Catalyst.
Okay, that's a catalyst. Now, what a catalyst does is it uh, increases the effectiveness of the collisions. It doesn't change the frequency of collisions. कि कैटलिस्ट डाला था उससे पहले भी 100 collisions हो रही थी, कैटलिस्ट डाल दिया अब भी 100 collisions हो रही है. The only thing that's happening is now previously there were 10 collisions that were successful. Now the effectiveness is higher. Now there are 20 collisions that are successful. So remember, the catalyst does not increase the frequency of the collisions. What it only does is it just makes them more effective. Is that clear?
Yes, sir.
अच्छा, अभी ये जल्दी से कर लेते हैं. Graph 1 results obtained at a higher temperature, that is possible. ठीक है. Graph 1 results obtained by hydrochloric acid that is more concentrated, so that's also possible. ठीक है, it's more concentrated, so faster. Graph 1 results are obtained using smaller pieces of. So all three are correct. All three would give a faster reaction. ठीक है, is this clear?
Yes, sir.
चले ठीक है, let's continue tomorrow then. ठीक है.
Okay, sir. Allah Hafiz.
Allah Hafiz.
Office.